Here we are, ENES100 Final Design Details Project Presentation, the culmination of a semester's worth of learning, all wrapped into one project. My name is Ali Hassania, and my three partners on this assignment were Elijah Mossman, Braden Marker, and Matt Valentino.
So our problem definition and refinement of design requirements, what we wanted to do is we wanted to create this device that could help keep track of a remote, and specifically an Apple TV remote, because they're small and they're easy to lose, and it usually happens um, where you're using this remote and then all of a sudden you put it back in a place and you can't remember where you put it, and then you take like 15 minutes trying to find it again. So we have come up with a device that will help you create this habit to keep track of your device. So it's a box, and what the box basically includes is a motion sensor. And on that motion sensor, when the TV remote is picked up and you start using it, a timer will start and say it'll give you 15 minutes for you to find your show that you want, or maybe change the volume, and then you have to put it back on the box, or a buzzer will start reminding you to put the TV remote back on the box. This case also comes with a charging port and a speaker. The possible stakeholders could be anybody with a remote, possibly Apple TV remote owners, and you could even further this technology to anything that you need help not losing. I know me personally, so I use a lot of pens because I'm using it somewhere and then all of a sudden I don't put it back and I end up losing it. So you could use this same sort of tracking device to help you keep track of where your lost items are.
So our external research and evaluations of existing solutions didn't lead to much. We ended up, all our research didn't give us much besides home remedies. We only found that people would tape sticks and spoons to the remotes in order to prevent loss, or people would buy covers for their remotes in order to prevent them from falling down cracks. So this is our design detail, and here you have the space for the remote paired with on the bottom right of the top face, you have the space for the button, and in the top right, you have the space for the LED screen. And on the like that side, this plate on the bottom plate, I guess you could say, you have all the little circle things for the speaker, for the buzzer, in order to make sounds. And we actually refined this design. And in the single hole where the remote goes, we ended up doing 2 double holes in order to make space for the distance sensor.
The bill of materials table for this project is relatively simple to follow. As seen below, I've broken it down into item, the amount of that item, cost per unit of item, and the total cost per that item. In total, we have 8 items. They include the PLA filament for the housing and for the components, an Arduino Uno, a breadboard, a distance sensor, an OLED display, a button, a buzzer, and various wiring. Each of these prices are listed, and the total price for our setup would be $61.60. Now this is if we got all the items individually. If we got them in bulk, like the school does, or an actual company, the price would be drastically less. When we wanted to test our design, we used certain validation methods. We wanted to actually make sure that our design held an Apple TV remote and functioned properly. This would mean that the OLED display would show a countdown for the user, would sound a buzzer if the remote wasn't returned in time, and be able to snooze if the owner was still browsing TV channels. It would only pass if all these cases were met. We tested the Arduino breadboard setup and the 3D printed model separately. The 3D printed model was tested pretty easily. Does it fit? Yes. Does the Arduino breadboard work? Yes. And together, they worked as well. This means that altogether, our design worked as we planned it to.
So we have our design evolution. Initially, the ideas that the four of us brought to brainstorming were, for the most part, just not feasible in and of themselves. But we based off those ideas initially, which is what you're supposed to do with brainstorming. There were a couple ideas that were such as using a light sensor and attaching a light to the remote, which would have been just not, it wouldn't have worked well. We finally came up with a feasible idea based off of those initial designs, but it had many flaws, obviously, as most initial designs do. So we sought feedback from peers, from Professor McAvoy, from AJ, and we made changes to our design accordingly. One of those being a snooze button so that you don't have to return the remote every 15 minutes. You can just press the snooze button. Instead, you would have to take the remote off the stand to charge it, which would set the alarm off after 15 minutes. So we added a charging port to the stand itself, things such as that. Then that was part of finding ways to eliminate flaws. We also changed the dimensions so that it would fit the Arduino underneath better. And then finally, once we had a design that eliminated all the flaws and worked well, we sent it over to the UMD lab and they printed it out for us. Our lessons learned, first of all, be thorough in the research of already existing solutions to the problem, because otherwise you're just going to create a solution to a problem that already has that solution, and marketability on something that's essentially already been created, it's not as good as something that's new and fresh and people are looking for. Secondly, communicate. Without communication, we'd end up doing the same thing. We'd have group members that work on the same thing not knowingly because we're not communicating. Communicating made everything easier, bouncing ideas off of each other, just talking and letting people know what you're doing and what needs to be done. Part of what goes along with that is equally distribute the workload. If one person's doing more work than another, it's okay if the workload is equally distributed for the most part, but like if it's very unequally distributed, then you end up with bad team chemistry because one person's mad they're doing more than the other. It's just, if you equally distribute the workload, then it gets done faster as well. Don't be afraid to make changes to your plan or design. If you don't make changes to your design, it's not going to be the best design possible because of the fact that you just initially came up with it in 5 or 10 minutes, and then that's the design that you go with. It's just not going to be as good as if you continually change it and make it better. Another thing is don't wait until deadlines. You do better work when you're not under a time crunch. Obviously, a 2-week something that's due 2 weeks from now is still a time crunch. But if you distribute the work equally throughout those 2 weeks instead of trying to get it all done in the last 2 days, it makes it a lot better work that you produce. Another one is plan ahead. If you plan ahead and decide what you want to do on this week or next week, it makes it so much easier to follow along. Just like the Gantt chart we started off the year with, that was very helpful to keep us in check and not fall behind on our work. And lastly, seek advice from others. We have 4 people in our group, and the same 4 people looking at the same design over and over again. We're not going to catch as many things that need fixed as a fresh pair of eyes. So having other, even if it's somebody that knows nothing about your design, just show the design to them, and they'll have ideas on how to fix it.